Question 17. A train travelled along a track in 110 minutes. Correct the nearest 5 minutes. Jake finds out that the track is 270 kilometers long. He assumes that the track has been measured correct to the nearest 10 kilometers. Could the average speed of the train have been greater than 160 kilometers an hour? You must show you working out. Okay, so the time, if I can draw properly, it's difficult to draw straight lines sometimes. So it's 110 minutes. So 105, 115. So we have here 112.5. And we have here 107.5. So this is time. And then for the distance, we have that as 270 kilometers. So this is 280. So this is 260. 265 here. 275. So this is distance. And so the upper speed, so remember our triangles, so it's distance, speed and time. So upper distance and the lower time, because we're trying to maximize, get the upper speed. So it's 107.5. So 107.5 divided by 60. This is, again, remember the 60 minutes, which is 1.7916 recurring. And then we have 275. So upper distance is 275, and then the lower time is 1.7916. So we get 153.488371. So no. So remember the question is, could the average speed of the train have been greater than 160? So no. Average speed not over 160 kilometers an hour, because this was the upper speed and we got 153. Jake's assumption was wrong. The track was measured correct to the nearest 5 kilometers. Explain why this could affect your decision in part A. Explain how this could affect, and it wouldn't. The maximum speed, sorry, the maximum upper bound would be lower. Because the track was measured correct to the nearest 5 kilometers. So that means that you'd actually be dividing by a larger number. So your upper speed would be a lower value. Question 18. So you have this here, this diagram here. So work out the arc, the length of the arc AB. So that's AB, and wants to work out the length. Okay, so we know this is 9 centimeters. We know this is X. And we know this is right angle, right angle. Okay, so we can see we have a right angle triangle here, right angle triangle there, but they're the same thing. So let's draw it out. If I can draw it out slightly reasonably, draw that there. So 9 here, X is there. 5 here, X is here. So we do sort Krakatoa. So this is going to be the, I'm going to do a different color. This is going to be the, this is going to be the opposite, because it's opposite the angle x. This is going to be the hypotenuse because it's opposite the right angle. And then this is going to be the adjacent. So we've got the adjacent, we have the hypotenuse. So we're going to choose this one here. So angle AOC. So we have AOC. So that's that one there. Is going to be, sorry, jumped a step. So cos x equals 5/9 using the the K. So therefore cos inverse 5/9 equals x, which is 56.25. So AOC, the angle, is going to be twice that, so 2 times 56.25, which gives us 112.50. I'm going to leave that as that. Then we have 360 take away 112.50, which is going to give us 247.5. And then we have 247.5 over 360 times 2 pi r. So remember, 2 pi r gives you, so this is a formula. Well, let's calculate that first and foremost. So r is 5. So 247.5 over 360 times by 10 pi, which will give us 21.6 to 3 significant figures. 21.6. Remember that formula for circumference is 2 pi r. Okay, so it's 21.6 centimeters. So this one here is 21.6 centimeters. So solve 19, solve this. So let's first treat that as an equality. So A is 2, B is 3, C is minus 2. So product, which gives us 2 times minus 2, which is minus 4. Two numbers that sum to give us 3. So we got 4, got 1, 4, 2, 2. So if we take minus 1, will give us, multiply them, give us minus 4. And then if we add, will give us 3. So 2x squared plus 4x minus x minus 2. Let's say that. So 2x x plus 2. So x plus 2. So we have here minus, so 2x minus 1, x plus 2, greater than 0. So in this case, x is equal to a half, or x is equal to minus 2. So if we draw out a, so let me draw that again, draw out a curve. So do that, so that's y, that's x. And then we know it's going to cross at half, and we know it's going to cross at minus 2. Don't worry about where it crosses the x-axis, sorry, the y-axis. So that's a half. And essentially we know that y is going to be greater, so it says where this is greater than 0, so we know that y is going to be greater than 0 here, y is going to be greater than 0 here. So when x is less than or equal to minus 2, less than 2, or when x is greater than a half, because we want this y essentially to be greater than 0. So x greater than a half, x less than minus 2. Question 20. The equation of a curve is y equals a to the power of x. A is a point where the curve intersects the y-x. State the coordinates. So crosses y when x equals 0, because the y-axis x equals 0. So y equals AO. Therefore y equals 1, because anything to the power of 0 equals 1. So we have 0, 1. The next part, it says that the equation of the circle C is x squared plus y squared equals 16. The circle C is translated by the vector 3, 0 to give circle B. Draw a sketch of circle B. Label with coordinates the center of circle B with any points of intersection with the x-axis. So we have, if I do this correctly, we have a grid, and we know that this is going to give us, so AB is going to be 0, sorry, the origin, so AB is going to be 0, 0, so that's the origin here, and then we have something that goes all around, so that's 4, it's minus 4, minus 4, and then if it moves 3, 0, so it moves 3, 0, so the vector, then we're going to have, this is y, this is x, where we're going to have 7, and the centers now move to 3, 0, and this is going to be minus 1, and so therefore we can see that this is going to be 7, 0, and this one here is going to be minus 1, 0. And then this point here where it crosses is going to be 0, 4 here. As if you just recall, this is always going to be a distance of 4. And that brings us to the end of the exam paper.